Welcome to 8 Series 105 Control and Monitoring Training Module. Here is what's covered in this module. Setpoint Group. In this section, we'll introduce how to select the active setpoint group, how to switch the active setpoint group, the priorities of the setpoint group, and how to inhibit change of the setpoint group. Trip bus. In this section, we'll introduce the function of the trip bus and relevant settings. Arc flash. In this section, we'll introduce the order code, hardware of the arc flash, the settings, and operands. Synchro Check. In this section, we'll introduce application of the Synchro Check, the requirement of the VTs, and the detailed setting applications. VT fuse failure. In this section, we'll introduce the different types of VT fuse failure detections through the logic diagrams. Breaker failure. In this section, we'll introduce the initiation of breaker failure, 3 different supervision conditions, and their relevant timer delays, as well as the low set delay applications with pre-insertion resistor of the breaker. Breaker monitor. In this section, we'll introduce the monitoring of the trip and closed circuit, the arcing current, and breaker health information. Monitoring functions. In this section, we'll introduce the monitoring functions of the power factor, demand, pulsed outputs, and digital counters. In the resources section, we'll identify other key resources to assist you, and finally, we'll summarize what we have covered in this module. So, let's get started. In the protection modules, we learned there are 6 setpoint groups in the protection element. By default, setpoint group 1 is active. So how can we switch to the other set group? It is controlled by the setpoint under Control, Setpoint Group. Automatic setpoint adjustment is available to change the settings when the power system configuration is changed. For example, by monitoring the state of a bus tie breaker on the bus connected to the associated feeder breaker. Different settings may be used, depends on the tie breaker state. Automatic group selection can be initiated by use of flex logic. The menu adjustment capability is available for those who use different settings for different seasons of the year. It is usually initiated from the keypad or wired communications. The active is setting groups is shown in the front graphic display. Group 1 is the default for the active group and will be used unless other group is requested to become active. The active group can be selected with the active setpoint group or by logic input. If there is a confliction in the selection of the active group, the higher numbered group will be made active. In some applications, the user may require that relay will not change from the present active group. This prevention of setpoint group change can be applied when any of the overcurrent, overvoltage, bus or line under voltage or under frequency element has picked up. 8 series provide 16 inhibit settings to block the change of the set group. Eight-series relay provides 6 identical trip bus elements. The trip bus element allows aggregating outputs of protection and control elements without using flex logic. Each trip bus has 16 inputs. It's like an OR gate with 16 inputs. By using the trip bus, the user can reduce the consumption of flex logic equation line by replacing OR gates with trip bus. In the next modules, we'll talk about the maximum flex logic line is 1024 lines in 8-series software. It is important to save the space when writing complex logics. Each bus can be assigned for either trip, alarm, latch alarm, or configurable. The launching and reset can be used for logged out and acknowledgement. The pickup delay and dropout delay are also available like the most protection elements. Arc flash function is available when the 10th suffix of the 8-series order code is letter F. When arc flash option is in the order code, the hardware of the relay will have 4 connectors in the rear side and 4 optical sensors. When arc flash function is enabled, the solid state relay from the output should be used to provide fast operation against arc flash event. The light sensor with high-speed overcurrent supervision ensures secure operation. In case any issues with the sensors are detected, the corresponding light sensor trouble operand are asserted. The Synchro Check function of 8-series is intended for supervising the parallel of 2 parts of a system which are to be joined by the closure of a circuit breaker. For example, 850 relay in the main bus transfer close before open scheme. If this feature is enabled, then the check will be performed before either manual close or automatic reclose signal can be operate the close output relay. By default, 3 VTs are used for bus voltage input and auxiliary VX is used for the line voltage input. Depends on the order code, both line and bus sides VT can be three-phase VT. Then the VT types must match. Under the voltage sensing, either both line and bus VT input should be set into Y or both set into delta. If both sides are single phase auxiliary VT input, then both auxiliary VT connection type must match. For example, if the line VT auxiliary VT type is VAB, then the bus side auxiliary VT should also be VAB. Synchrocheck verifies that the voltage of the bus and line on the two sides of the supervised circuit breaker are within the set limit of magnitude, angle, and frequency difference. The time during which the two voltage remains within the admissible angle difference is determined by the setting of the phase angle difference delta phi and the frequency difference slip frequency delta f. When delta phi is 30 degrees and delta f is 0.1 Hz, then the calculated time will be 1.66 seconds. As a result, the breaker closure time must be less than this computed time to successfully close and connect both energized sides. For the hysteresis setting, once the Synchrocheck element has operated, the frequency difference must increase above this sync max frequency difference plus the sync max frequency hysteresis sum in order to drop out the relay. The Synchrocheck programming can allow permitted closure if either or both of the sources are de-energized. Dead source permission provides the combination of dead and live sources that bypass the synchronism check and permits the breaker to be closed when one or both of the two voltages are below the maximum voltage threshold. There are 6 options. Disabled, that's dead source permission is disabled. Live bus and dead line, dead bus and live line, dead bus and dead line, dead bus or dead line, dead bus exclusive dead line, which means one source is dead, another one is live. For these logic conditions, the live and dead voltage level must be defined. Live bus and line minimum voltage that defines the voltage source is live or energized. Dead bus line maximum voltage defines the maximum voltage magnitude below which the voltage source is dead or de-energized. Once permit is set and all conditions are met, then sync dead source OK operand will be sent to the transfer scheme. If magnitude, phase, and frequency differences are all below the settings, then sync1 close permit operand will be asserted. The VT fuse failure function in 8 series can be used to raise an alarm or block elements that may operate incorrectly for a full or partial loss of VT potential caused by one or more blown of the fuses. Depends on the order code, user may select the CT and VT inputs for the calculation of the positive, negative, and zero sequence current and voltage. There are two classes of fuse failures that may occur, Class A and Class B. For Class A, it is loss of one or two phases. For Class B, it's loss of all three phases. An indication of Class A failure is a significant level of negative sequence voltage. Indication of Class B failure is the presence of positive sequence current and an insignificant amount of positive sequence voltage. In the logic diagram, we can see there are two output operands, VT fuse 1 V loss and VT fuse fail up. The VT fuse 1 V loss is caused by, first, there's no Class A category asserted. And second is the positive voltage is below 0.05 pu. The VT fuse fail 1 up can be initiated by 4 conditions. The first one is there's no fault. The second one is either from Class A or Class B category initiation. The third is 50 dD not initiated. So 50 dD, this operand, it detects the 2 cycles out of the positive, negative, and zero sequence current. And the first one is voltage and current cannot be both lost. The VT fuse fail 1 up will be reset when the negative sequence voltage is dropped and the positive sequence voltage is up, which stands for the healthy status, or both positive sequence V1 and I1 are below 0.5 pu, which stands for losing both current and voltage. Eight series relay provide 1 or up to 4 breaker failure elements. The breaker failure scheme trips the backup protection breaker when the primary breaker fails to interrupt the fault current. When the function is set to retrip, the scheme will be initiated by the phase or neutral current higher than the retrip supervision pickup. It immediately sends a trip signal to the breaker initially signaled to trip. In this way, it reduces the possibility of widespread tripping from a declaration of a failed breaker. This feature is usually described as retrip. The scheme determines a breaker failure condition supervised by one of the conditions: current, breaker status and current, or breaker status only. breaker closed selects the flex operand to indicate that the circuit breaker is closed. When there's a confliction of this breaker closed settings with the setting of the breaker under system, the setting in this breaker failures, breaker closed prevails. Each type of the supervision is equipped with a time delay, after which a failed breaker is declared and trip signal are sent to all breakers required to clear the zone. The delay are associated with the breaker failures timer 1, 2, and 3. We'll explain this more in the logic diagram. The timer 1 and 2 logic provide two levels of the current supervision, high set and low set. That allows the supervision level to change. For example, from a current which flows before the breaker inserts an opening resistor PIR into the faulted circuit to a lower level after the resistor insertion. The low set delay interval is the expected breaker opening time. Different breaker manufacturer has different design of the PIR pre-insertion resistor. It is important to understand the sequence of the PIR operation during opening before setting this parameter. The breaker failure initiation can be from external with flex operand or with 15 internal protection operands like the phase, TOC, IOC operand or neutral TOC, IOC operate. In the logic diagram of breaker failures, we're going to introduce the operand of breaker failures retrieve and breaker failure operand. Then the timers of the T1, T2, T3 and the low set delay. The breaker failure retrieve, this can be initiated once the retrieve function is enabled. Any internal or external initiation can trigger this retrieve. And the retrieve is used to trip the local breaker. For the breaker fail up, this is used to trip the remote breaker. The three timers corresponding to three supervision conditions. T1, this is used for the current supervision conditions only. And T2 is for both auxiliary contact and current supervision conditions. And T3 is only used for the breaker contact supervision. And low set delay is used for the PIR pre-insertion resistor application. And this should be the breaker opening time. So all these conditions will drive to the final breaker fail operand, and this to use to trip the upstream remote breaker. The health of the trip circuit can be monitored when jumper is wired from DC positive side to F3 of the trip contact. When the main breaker is closed, the trickle current will pass through the voltage monitoring circuit and 52A auxiliary switch without tripping the breaker. When the main breaker is open, then monitoring circuit is interrupted. Some applications require monitoring of the trip coil continuously, regardless of the breaker position. This can be achieved by connecting a resistor across the breaker auxiliary contact 52A in the trip circuit. With such connection, the trickle current is maintained by the resistor. Meanwhile, the setting of the bypass breaker state should be set to enabled. Similarly, the closed circuit can also be monitored when the jumper is wired from DC positive side to F6 of closed contact. When the main breaker is open, the trickle current will pass through voltage monitoring circuit and 52B auxiliary switch. A bypass resistor can be connected, like in the trip circuit, in order to monitor the closed coil continuously, regardless of the breaker position. Similarly, the setting of the bypass breaker state should be set into enabled. The breaker arcing current element calculates an estimate of per phase wear on the breaker contacts by measuring and integrating the current squared passed through the breaker contacts as an arc. These per phase values are added to the accumulated total for each phase and compared to a programmed threshold values for alarm. The initiation selections which operand to start arcing current accumulation. The breaker opening has contact separation and arcing 2 stages. In order to subtract the arcing current through the pure breaker metal contacts, a programmable delay is introduced between initiation and starting of the integration to prevent false integration. This interval should include the operating time of the output relay, any other auxiliary relays, and the breaker opening. For maximum measurement accuracy, the breaker operating time should be measured with a breaker motion analyzer. After contact separation, the integration of the measured current continues for 100 milliseconds, by which time most modern breakers will have cleared the fault. Alarm level is total arcing current in kiloamps squared cycle. Check with the breaker specification to enter an accurate alarm level for this feature. The information of the arcing current can be found under the breaker report, which is under records, breaker records. So all the arcing current information is displayed here. 8 series relay provides breaker health information by monitoring and analyzing these parameters: operation count, arcing energy of breaking current, arcing time, tripping time, closing time, spring charging time, and incomplete charge time. All these factors together reflect the breaker health status. There are 2 modes of the breaker health: detection and monitoring. The detection mode can be used to help set the pickup level based on the historical true values. The operation count, arcing energy of the breaking current, arcing time, tripping time, closing time, and spring charging time are measured and displayed in this record breaker health report. but the element does not pick up when in detection mode. Monitoring mode is the normal mode wherein measurements are analyzed and the element may pick up accordingly. The operation count is able to give direct information by comparing it with the permissible operation number. The longer arcing time may suggest the loss of the longer tripping time and closing time can provide an approximate estimate of the trip and close coil and mechanical wear. The longer arcing time may suggest the loss of dielectric stress in the arcing chamber. The increase in spring charging time may imply the development of problems in motor and spring mechanism. The increase in arcing energy of the braking current may reflect the possibility of contact wear. If the arcing current is disabled, the arc energy is not calculated and this setting should not be used. The arc energy used here is the individual values for each trip and not the accumulated values recorded in the breaker arcing current element. The scheme is equipped with 3 incomplete sequence timer for trip close, for the arcing, and the charging time. It is automatically resets the related time interval after the programmed delay. Power factor can be used to control the capacitor bank to the circuit to compensate for low lagging power factor. The switch in and out setting can be set to lead or lag by entering the positive or negative values. When the positive values is entered, the lag power factor is displayed. When the negative values is entered, then the lead power factor will be displayed. When the measured power factor becomes more lagging or leading than the switch-in level, the relay operates at a user-selected output contact to control the connection of the capacitor bank. After entering this state, when the power factor becomes less lagging or leading than the power factor switch-out level, the relay resets the output contact to the non-operated state. Current demand is measured on each phase and on 3 phases for real, reactive power, and apparent power. Set points allow emulation of some common electrical utility demand measurement technique for statistic or control purposes. The relay can be set to calculate demand by any of 3 methods. Thermal exponential. This selection emulates the action of a mechanical thermal demand meter. In the mechanical meter, the heating and cooling of the coil does not happen instantaneously. To emulate this time lag, 8 series use these equations to calculate the thermal demand. K is 2.3 divided by thermal 90% response time, and default time is 15 minutes. Block interval. This selection calculates a linear average of the quantity over the programmed demand time interval starting daily at midnight 12 a.m. Rolling demand. This selection calculates a linear average of the quantity over the programmed demand time interval in the same way as block interval. The value is updated every minute and indicates the demand over the time interval just preceding the time of update. The current demand for each phase is calculated individually, and the demand for each phase is monitored by comparison with a single current demand pickup level. Thermal 90% response time set point is visible only when the measurement type is set to thermal exponential. And the time interval set point is visible only when the measurement type is set to block interval or rolling demand. The metered values of the demand can be viewed under the metering, current demand, and from here we can see the current demand, maximum demand, and the date and time of the demand. Pulsed outputs function can provide a pulsed output for full energy measurement. It can operate auxiliary relays after an adjustable energy increment for the quantity of positive and negative megawatt hours and positive or negative megawatt hours. Pulses occur at the end of each programmed energy increment. Keep in mind, 8-series relay is not a revenue class meter and cannot be used for billing purposes. 8-series relay provide 16 identical digital counters. A digital counter counts the number of state transition from logic 0 to logic 1. The digital counter are numbered from 1 to 16. The counters are used to count operations such as pickup of elements, the change of state of external contacts, like the breaker auxiliary switches, or the pulses from watt-hour meters. The status of the digital counter is not under the metering or the status, but it's under the records. So under records, there's a digital counter. And we can check the status of the digital counter. So if I turn on the counter 1, I can use this to increase the counter. And I can use the counter 2 to reduce the counter. And I can use the counter 3 to preset the counter. And I can use counter 4 to reset the counter. And counter 5 can be set to the frozen, and counter 6 can be set to the count. And for these counters, this will be used to compare our preset values, and then this will be used to operate the output relay. Depends on this is higher than the preset values, equals to the preset values, or the lower preset values. The technical resources we used are 8-series manuals, especially Chapter 4, the set points, the section of control and monitoring. Now let's recap what we have learned in this module. We started with the Setpoint Group. At this moment, you should know how to switch Setpoint groups, the priorities of Setpoint Group, and how to inhibit the change of the Setpoint Group. Next, in the trip bus, we compared it with a 16 inputs OR gate. You should try to use trip bus instead of OR gate in the future FlexLogic programming to save the space. In the ArcFlash session, we introduced the order code and hardware of ArcFlash. The optical sensor is supervised by overcurrent to ensure the security. And remember to use solid-state relay SSR for this function. In the Synchrocheck session, we introduced the parameters of three differences in magnitude, phase, and frequency, as well as dead source permission options. In the VT fuse failure, we introduced different categories of fuse blown, partially or whole three-phase, how the relay internal logic detects them and differentiates them with normal conditions and a real fault. Pay attention to the operand 50DD disturbance detector, how it is used in the supervision. In the breaker failure session, we introduced the retrip operation, the three ways of initiation of the breaker, and related three time delays. Don't forget low set delay is used for the breaker with a pre-insertion resistor. In the breaker monitor, we convert the trip, closed circuit monitoring, the arcing current, and breaker health monitoring. And lastly, in the monitoring functions, we introduced power factor, switch in and out controls, three modes of demand measurement, pulsed outputs for the megawatt-hours and megawatt-hours measurement, and digital counters settings and applications. Don't forget the actual values for the digital counter is under records, not under the metering or status. That brings this learning module's 8SP 105 control and monitoring elements to a conclusion. We hope you found it informative, and let me close with thank you for watching and wish you good luck with your future studies.